Hello! Today we are going to be starting chapter 3, and some of you guys will be excited to hear that we are going to be moving away from proofs. What we're going to be working on today are a bunch of relationships that are formed by transversals. Now, transversals are, as you guys can see, lines that intersect two or more coplanar lines. In other words, it's just a line going through a couple other lines. So this right here is a transversal. So is T in this picture. We can also have transversals that go through a series of lines, so don't be shocked if you see something like this where our transversal is coming through 3 lines. And also be aware that sometimes transversals are going through lines that are not parallel, like this guy. So eventually the other 2 lines that it's going through are going to intersect. So here we actually have 3 unique transversals. I could talk about how this line right here is a transversal of the other 2. But I could also talk about each of these other 2 lines as a transversal. This one is a transversal of these 2 lines. Now these are less likely to be talked about, and that's because when we have lines like this, where it's going through what appear to be parallel lines, there are going to be some special relationships, and we're going to be able to form some formulas for those ones. Now let's start by giving labels for special types of angles when we have a transversal. Now notice how these ones are just pictures describing kind of the same situation. We've got transversal coming through lines L and M, or let's just call these ones L and M to keep it consistent. And this one's 1, 5, 2, 6, so on and so forth. When we're talking about these, we're going to be talking about interior angles and exterior angles. Interior angles are all of the angles that are inside the 2 lines, and exterior are all the angles that are outside. So like 1, 2, 8, and 7, 1, 2, 8, and 7, those would be our exterior angles. Now, when we're beginning our terms, we're going to have first what's called a corresponding angle. And you can think of corresponding as it's in the same spot. It's on the same side of the transversal, so they're both on the left or both on the right, and they're going to be on the same side of the other line, so the L and the M. For instance, if I'm looking for the corresponding angle for angle 1, that's going to be angle 5. And that's because angles 1 and 5 are both to the top left. And you guys could see that in either picture. We can also say that angle 2 and angle 6 are going to correspond. Again, same spot, top right. We can keep going for each of these, and each of these angles is going to have a corresponding angle. 3 and 7, and last but not least, angles 4 and 8 are also corresponding. Now when we look at corresponding angles in a special case, like parallel lines, we're going to be able to conclude one other thing. So let's say that these have been marked parallel. If they're marked parallel, corresponding angles are going to be congruent. So angle 1 will be congruent to angle 5. In other words, the measures of these 2 angles are going to be equal. And you guys can see that for each of the corresponding angles with those parallel lines, they look like they are the same. 2 and 6 correspond, and those 2 are also equal. And you could keep going with the rest of them. Now, if the lines are not parallel, this will not be true. Even looking at this, I can see 1 and 5 are clearly not the same. Same with 2 and 6, even though they're corresponding. So make sure you only use these formulas for those parallel lines. For our next one, alternate exterior angles, we are going to have alternate exterior angles on the opposite sides of the transversals outside the other lines. So I'm going to look on the exterior, 1 and 2, 8 and 7. 1 is going to be the alternate exterior angle to 7 because it's outside the lines and on the other side of the transversal from 7. So angle 1 and angle 7 are going to be alternate exterior. Similarly, 2 is going to be the alternate exterior angle to angle 8. And that's because, again, they are exterior angles and 2 is on the opposite side, the alternate side, the right versus the left. And it turns out that when the lines are parallel, alternate exterior angles are also going to be congruent, just like corresponding angles. And you can actually prove this using our previous theorem. And here's basically why. If I look at 1, I know that that's congruent to 5. And 5, I know would be congruent to 7 because they're vertical angles. Therefore, 1 and 7 would have to be the same measure due to those reasonings. So I could continue writing the formulas. 2 and 8 would also be congruent, but I'm just going to give 1 here. For our next one, we're talking about the alternate interior angles, and this is very similar to the one above. We're talking about the angles on the inside of these lines and on opposite sides of the transversal. So that gives us angles 4 and 6, 4 and 6, alternate interior, and angles 3 and 5. Just like before, you can kind of look at and see how these would, in the end, be equal. 3 would be the same measure as 5, and that's because 1 is a vertical angle to 3, and 1 corresponds with 5. So 5 is equal to 1, which is equal to 3, so therefore they must all be equal. That means that I can write in my theorem section for parallel lines, angle 4 is congruent to angle 6, or they have equal measure. Keep in mind, again, and I can't say this enough, this only works for parallel. It will definitely not be the case with the 4 and 6 on this one. We can see they're not the same. Last but not least is kind of like our odd one out, and that is what's called the consecutive interior angles. Consecutive interior angles are on the same side of the transversal between the other lines. So we're talking about angles that are inside, 3 and 6, and between the lines on the same side, 4, 5. And that's just because they're consecutive. They're in a row. We don't usually talk about the 1 and the 8 and the 2 and the 7, though they will have a special relationship with parallel lines. It's just, it gets kind of an awkward wording, and they aren't talked about quite as much, so we really limit it at consecutive interior. So our pairs of consecutive interior are going to be 4 and 5, and then angles 3 and 6. And again, same with this picture, 3 and 6, 4 and 5. Now, if you look at the relationship between these in parallel lines, well, notice how 7 and 6 are a linear pair or supplementary in the end. So that means that if 7 is the same as 3, 3 and 6 would also have to be supplementary together. So that means that if I took the measure of angle 3 and I added the measure of angle 6, or the measure of angle 4 and I added the measure of angle 5, I would get 180. They're going to be supplementary. So watch for these because these are going to be your formulas. And be really careful with this one that you don't accidentally set them to equal because we're used to dealing with equality. All right, let's play with these a little. Let's start with this guy. So right now, obviously, I can't fill in any measures. Let's say, though, I told you that angle 2 is equal to 50 degrees. And I asked you to fill in as many as you knew. Well, currently, I can only fill in these 4. I know that 3 is at 50 degrees as well because it's equal. I know that 1 is a linear pair, so they're supplementary. Therefore, that would have to be 130. And since 4 is a linear pair to 2 as well, that would be 130. But I can't actually fill in anything about these. That's because I can't use any of my extra formulas that I found on the chart here because currently these lines, I do not know that they're parallel. They sure look parallel, but I don't know it. So let's say that it did come with parallel markings on it. So as a teacher, I'm going to tell you, add those parallel markings. They are for sure parallel. Well, at that point, you're actually going to be able to fill in all of them. Since this is a corresponding angle to 1, it will be equal, or 130 degrees. And that means I can solve for each of the other ones, giving us a 50 degrees for 6, 130 degrees for 8, and 7 will have a measure of 50 degrees. For our next one, I'm going to have to be careful what formula I set up, and it will depend on the positioning of these. Well, first off, I know that they're parallel lines. It has the little markings here. So I know I can use the formulas that I found earlier. These are on the same side on the interior. So that means that they are consecutive interior angles, same side and between the other lines. That means that the sum of these two angles, and I'm just going to call this one angle 1 and angle 2, is going to equal 180. Which means I can substitute in the values I have, x plus 75 for the measure of angle 1, and x plus 125 for the measure of angle 2, and I'll be able to solve. That will give me 2x plus 200 is equal to 180. Subtracting 200, I get 2x is equal to a negative 20. And last but not least, that tells me that x is equal to a negative 10. A lot of people will see this and say, well, that can't be right because you can't have a negative angle measure. Well, that might be the case, but we aren't actually saying that the angle has a measure of negative 10. We're saying that x has a measure of negative 10. And so x here would then get substituted in. And so I'd have negative 10 plus 75 to get the measure of angle 1. And that means that the measure of angle 1 would actually be 65 degrees, which is a positive number, and that makes a lot more sense in the context. And here I could substitute in the x again, or just remember that these make 180, and I'd end up with the measure of angle 2 equaling 115 degrees. That does work, and we'd be good to go. For our final problem, we're going to have to take a few steps. When I look at these, I notice that I have x's and y's. And remember that in order to solve for a variable, you can't have more than one variable in the equation to truly solve it and get a number. So what I want to do is I want to be able to set up an equation that has only x's in it and use that information to solve for y. So let me start with the relationships. I know that these two lines are parallel. So these two angles are going to be equal, and since this angle corresponds with this angle, it will also be equal. These are alternate exterior angles, so again, those two must be equal. And this one over here, the 5y plus 15, is going to be our only odd one out, where he doesn't equal the other two, though he does form, he is a supplementary to a few other ones. So let's start with finding an equation for x. Well, I could say that this is equal to 3y plus 5, so 17x equal or minus 70 is equal to this. But again, I don't really want a y in the equation. But I do know it's also equal to 2x plus 5. And that is another equation or expression with x in it, which is nice because that means I'll be able to solve for x. So let's do that. I'm going to combine this to get 15x on the left when I subtract 2x, and 75 on the right when I add 70. Divide by 15, and I end up with x is equal to 5. Now for the second part of the equation, I could solve this a couple different ways. For instance, I could put x in and say, well, since x is 5, that would be 2 times 5, or 10, plus 5, which would give me 15 for this angle here. And I could use that to solve for this angle, and I could go through those steps. Or I could take the formula that we had above and say, well, these are consecutive interior angles, so that means that 3y plus 5 plus this one, 5y plus 15, is going to equal 180. And I can solve it this way. That would give me 8y plus 20 is equal to 180. Getting y by itself would be 8y is equal to 160. And dividing by 8 tells me that y is equal to 20. And that would be a way to solve for it. Again, there are a couple ways you can get to these answers, and yours might be slightly different than mine. That's okay. Go ahead and explore and have some fun. The homework is posted online. Feel free to send me any questions that you have. Revisions for proofs can be submitted at any time, and the earlier you can get them in, the better, because then I can get your feedback earlier. We're going to have a 2-proof quiz on Thursday, so make sure you're ready for that. Have a great day.